21. Okay, it's going to be section 5.2. Okay, 5.2 and 5.3 at the same time. So what is going to be this section all about? This is going to be integrating by substitution method, or just substitution method. Substitution method. So it's going to be this one. Remember, the notion of the integration is going into the past. The derivative is the future, is the rate of change. When you're given a function, we find the derivative of the function, we predict. But integration is the derivative is already given to you. So we want to recover the function. So we go into the past, going back. That's why we call it anti-differentiations, if you like. What we did so far, remember, we just dealing with some functions, mostly power function or combination of powers. You see the radical, you get the rational functions, and that would take us back to the original one. But we didn't touch the type of function that when we want to differentiate, remember, we use the chain rule. Formula, the famous formula for the chain rule, if you remember, was u to the n. The derivative of u to the n was nu to the n minus 1 times u prime. We are going to create something converse to the chain rule. So instead of writing the formula right away, I want to motivate it to understand it, and we get the formula. So let's recall what we did for the chain rule. Okay, recall that. You see, we recall that if this function is given to you, say if, let's say, f of x is equal to something like 3x plus 1 to the fifth. Okay, remember, this is, if you want to differentiate it, we just call this one u. So this would be something like u to the fifth. And if you want to differentiate u to the fifth, it would be 5u to the fourth times u prime. So if this was the case, then by chain rule, we get the f prime of x is going to be equal to the what? Is going to be 5 times 3x plus 1, okay, to the fourth, but times the u prime. U prime is 3. Okay, so that was the one that we got it for the chain. You know that if you just think about this one over here, this is just like the function that we did before. If this is given to you, you want to find a function whose derivative is given to you. So you know that function. This is going to be that function. So we can say that this equivalently, this means, if you want to write it down in the language of the integral, equivalently, this means integral of 5 times 3x plus 1 to the fourth, okay, times 3 dx. So this means you want to find a function whose derivative is given to you. You know that function. That function is what? Is a 3x plus 1 to the fifth. And you can add the constant c at the same time. Okay, because you know that the derivative of this function is the given one over here. Now let's do a little bit of algebra. The little bit of algebra is going to be, you see, what I'm going to do for the algebra part is I'm going to take this 5 out. It's a number, I can do it. So I take this 5 out. So that gives me 3x plus 1 to the fourth. And I put these two together, there's going to be 3dx. Okay, and this is going to be equal to the 3x plus 1 to the fifth plus c. Okay, so I'm going to divide both sides by 5. If I divide it by 5, so that gives me 3x plus 1 to the fourth. And this is going to be 3dx. Okay, and this is going to be 3x plus 1 to the fifth over 5. Okay, this constant c doesn't matter. C over 5, all of them are going to be c. Now look at this one. And think about that, the formula for the chain rule that we usually use. So from that point of view, if you call this one u, okay, so if you call 3x plus 1u, remember the differential of the u? Differential of the u, if you remember, was derivative of the u times the dx. Derivative of the 3x plus 1 would be u prime. So this portion over here is going to be what? Is going to be u prime dx. Okay, so if with this u things that I write it down, that give me u to the fourth. That's a u to the fourth. Then over here I have the u prime dx. Okay, and over there I'm going to have u to the fifth over 5 plus the constancy. That u prime, you see, u prime the dx is the one that we call it differential of the u before. So u prime dx, we can substitute it by du. So what I'm going to have is going to be what? Is going to be u to the fourth du is what? Is u to the fifth over 5 plus the constancy, which is nothing new. You see? It's exactly the power rule. It's going to be the power rule because the u is given to you, add 1 and you divide. You see, this is this is going to be kind of we call it the general power rule for integration. So integration, the actual rule is x to the n dx, x to the n plus 1 over n plus 1. So this means if you want to get the kind of reverse or converse to the chain rule, you are going to have this formula. So we can say that in general, that was just a motivation, but in general, this is what you're going to have. If u, which is equal to the u of x, means it's a function of x, is going to be differentiable. If it's going to be differentiable, means if you can find u prime, then this is what we have. We have integral of u to the n du, as we did for the x to the n, action of integration, u to the n plus 1 over n plus 1, okay, plus the constancy. Exactly the same as integral of x to the n. But there is this du, because when you want to integrate it, you see, when you want to integrate it, everything would be in terms of the x. So you have to note that where or when, where this du is simply what? Is going to be u prime differential of the u. Remember, u prime times dx. You see, we create this formula to be able to take care of the integration of the chain rule type. Remember, the chain rule type was what? Was something like, you know, a parenthesis root raised to the 5 to the 6. It was a radical function, we switched the radical. If it was a quotient function, we switched that. So as soon as we get to those type of ideas, we have to change it to the u form, we call it. That's why this is called substitution method. So the substitution method means you have to change it into the u form to be able to do it, okay, for all those type of problems. Of course, this formula can be used all the time, but except you know that when n is not equal to the -1, and you know that if it's going to be -1, then we can apply the, okay, we can apply the natural log to get these numbers. So in this method that deal with this type of integrations, we are going to call it substitution method. So you substitute, you change the function from the x into the u, and it's nothing new. It's nothing new soon because the result is going to be just the power rule. The result is going to be just the power of the function, and you just take care of it, and that gives you the final answer. Okay, so I'm going to try it to show you how we're going to operate with the substitution method, and we can do any, you know, yours are easy. In the calculus 1, 2, 3, we have various type of function, trigonometric function, and this method is the key for all integrations. Okay, so we are going to use the general power rule. We call this one general power, like the derivative. We have x to the n and we have u to the n. Now we did the same thing over here. Okay, let me give you one example to see, and then if you have any question, then we can continue with this one. Okay, so let's see how we operate for this substitution method. As you did for the chain rule, 4 types of function, and you're going to have 4 types of integration, and all the 4 would be given to you. Okay, so we give you the instruction. So you can't miss it. We are going to ask you evaluate. Okay, evaluate each integral by substitution method. You have no other choice, of course, or just by substitution. By substitution method. The students usually refer to it as a U sub because you just substitute. Okay, so let's go with the type 1. Okay, the first one is going to be a type 1, like integral of, okay, like integral of, let's have something like 3x squared times x cubed plus 1 to the 10 dx. You see, as soon as you see these parentheses, it's for differentiation, it was a chain rule type. It's the same for integration. It's a chain rule type. Substitution method, so whatever it is inside the parentheses, you are going to call it u, and then you change it. When you change it, everything should be simplified, and you must end up with the u to the 10 du. U to the 10 du would be u to the 11 over 11. Okay, your answer is clear, but you have to design it to get this number. Okay, so this is how we're going to do it. Step 1 for all these problems. You have to pick the u. U is inside parentheses, you see, inside. This is always u. Okay, so we're going to get the u, and you have to explain all the steps. There are some very nice calculators that give you the result right away. So if you write only the result on the test, you get 1 out of 10. It's called substitution method. So you have to show us how you did substitute to get the result, okay? So you take the u to be x cubed plus 1. That's step 1. Now you have to find the du, differential of the u. What is the du? Is the derivative of the u times the differential of the x, dx. So derivative x cubed plus 1, derivative of x cubed plus 1 will be 3x squared. So this is going to be 3x squared, okay, 3x squared dx. Okay, so what you have so far, I rewrite it. You have that the du is equal to 3x squared dx. Now you have to find the dx because you want to substitute. So what's going to be the dx? Dx, if you want to solve for dx, you divide by 3x squared. So it's going to be du over 3x squared. So this is going to be your first step for all this problem. Any question? So you pick the u, whatever it is inside the parentheses, you must end up with the u to the 10 du. So you have to find the du. Du is u prime dx. You differentiate, then times it by dx. Then you find the dx. To find the dx, you divide by this coefficient. It's going to be always du divided by something. Now go back and substitute. If you have done everything all right, you must end up with the u to the 10 du. Okay, so originally we have a 3x squared times x cubed plus 1 to the 10 dx. Substitute. You don't have anything to substitute for 3x squared, so don't worry. You just keep it. This is the one you call it u, so that would be u to the 10, u to the 10. Then the dx. The dx is du over 3x squared. Du over 3x squared. Any question? So you should clear out those x's. You cannot have any extra x here. So you see the 3x squared and the 3x squared would be out. You may end up with a number. Number is fine, but not x. Okay, so you simplify that, give you 1, that give you 1. So the leftover is as you predicted, is u to the 10 du. See? U to the 10 du, just a power rule. So it's going to be u to the 11, 1 up, u to the 11 over 11 plus the constant c. Substitute for u. What is the u? X cubed plus 1, okay, to the 11 over 11 plus the constant c, and you're done. You don't have to, but I like to rewrite it to highlight the result. 3x squared x cubed plus 1 to the 10 dx. I end up with what? End up with the x cubed plus 1 to the 11 over 11 plus the constant c. You see? That would be the final answer. Any question? Very nice method. There are shortcuts, you know, in future, we just do it right away. But not now. You see, in future, this is a chain rule. You need u prime, you see? U prime is 3x squared. As soon as we get the u prime, we say we have a deal, which means this is u to the 10, would be u to the 11 over 11, and you're done. You see? That's going to be what? X cubed plus 1 to the 11 over 11 plus c. But there are some other cases that you may miss something, and we just want to practice to get, you know, to get this one through. Any question? That's type 1. Everything was nice. Let's see what's going to be the type 2. The algebra would be different. Otherwise, the format of this question is all as is. Okay, so that was type 1. Type 1, as with the differential, is a parenthesis raised to something. So it's going to be type 2. You see the type 2 one, as we did with the chain rule, a radical function. How about integral of, okay, integral of cube root of 5x plus 1 dx. That's a type 2. You know what to do? We don't like the radical. So we have to switch radical, as we did when we want to differentiate it. So the first step is rewriting. So you realize that this is what you have to find. 5x plus 1 to the third, okay, the dx. So this is it. Whatever is inside the parentheses, you call it u. So you call 5x plus 1 u. You simplify, you must end up with the u to the 1/3. Okay, so u would be 5x plus 1. That is step 1. Step 2, differential of the u, du. du is u prime times dx. U prime is 5. 5 times dx. You have to find the dx. To find the dx, we divide by 5. So it's going to be du divided by 5. So that is going to be u and the dx. Any question? Go back, substitute here. So we substitute what's going to be the result. So we have the integral of 5x plus 1 to a third. Okay, at dx, so it's going to be equal to the integral of. This is the one they call it u. It's going to be u to a third. Okay, then we have a dx. What is the dx? The dx is the du divided by 5. You see, there is nothing to simplify. So there's going to be leftover here, 1/5. So you can rewrite it as 1/5. Okay, 1/5 u to the 1/3 du, because it's a number. Since it's a number, you can pull it out. Okay, you can put it out, that give you 1/5. So that would be 1/5 integral of what? U to a third, u to the third du, as we predicted. See, we predict that we should get u to the 1/3 du. Power rule. So we give the fifth 1 up, the power is going to be u to the, it's a 1/3 plus 1. 1 plus 3 would be 4, so that gives you 4/3. Divided by the 4/3 plus the constant c. Remember, since you're dividing by a rational number, you have to multiply by a reciprocal. So it's going to be 1/5, flip it. So that gives you 3/4, and that would be u to the 4/3 plus the constant c. So that gives you 3/20. That would be 3/20. And the u, what is the u? U is 5x plus 1 to the 4/3 plus the constant c. That gives you the final answer. You see, that's a type 2. The type 2, you have a radical over here. Okay, so it doesn't matter the radical. Just we do the okay, this is going to be the 1. Du is a differential of the u, not the derivative. Differential, remember, it's going to be u prime dx. That is, when we say differential, is a derivative times the dx. That's what we do over here. You see the du. Because you need that dx to be able to find it. So the extra point was here that we get a fifth, doesn't matter. It's a number. As long as it's a number, that's safe. If it's going to be x, you'll be in trouble because you cannot have the u and the x at the same time. You see, since you change into the u, so you must end up with the u and the du. No more x. If you get the x, probably you miss something. You have to go back and double check, okay, double check whatever you have, because your formula is standard, u to the n du. Okay, any question? That's a type 2. As we did with the derivative. What's going to be type 3? Remember when we did the chain rule, the type 3 differentiation for the chain rule was a quotient function. Okay, and we give you a recommendation over there, and we are going to use it here again. So what is going to be type 3? You see, the type 3 is like this. You have something like, let's say you have x squared over there, okay, or x cubed on the top. So we have x to the 4th plus 1, everything to the 6 dx. Remember recommendation that we talk about it for the chain rule when we want to differentiate a rational function. We told you that if there is no power here, you stay where you are. You're not going to move it up. If there is a power here, you move it up. It's going to be the same here, and you must follow these rules. So in this case, we have a 6 here. You move it up, then you can do it. If the 6 was missing, you stay where you are. Because when there is a parenthesis, this is going to be your u. So you move it up, eventually you end up with the u to the -6. But when there is no 6, it's going to be u only. So when you change it, you end up with the 1 over u du. You know that 1 over u du is the integral of the ln function. So that's why you shouldn't move it up when there is no power here, okay? So there is a power, you have to rewrite it. So the solution is going to be, you rewrite, we get what? We get the x cubed times it by x to the 4th, okay, plus 1 to the -6 dx, you see? It's just a type 1 again. So again, inside the parentheses, you call it u. And if you do everything all right, you must end up with the u to the -6 du. Okay, so pick the u. So your u would be what? Would be x to the 4th plus 1. This is the u. You find your du, differential of the u, is the derivative of x to the 4th plus 1 would be 4x cubed times the dx, differential of the x. Any question? You have to find the dx. So to find the dx is equal to, it's going to be du divided by the leftover here, which is 4x cubed. 4x cubed. That's it. You have the dx and you have du. Any question? Go back, substitute. You must end up with u to the -6 unless you miss something. So we repeat it, x cubed, x to the 4th plus 1. Okay, x to the 4th plus 1 to the, that's a -6. dx, I just repeat it, it's going to be equal to integral of. We don't have anything for the x cubed, don't worry. We should be able to cancel it out. The inside is u, so that gives us a u to the -6. Okay, and we have the dx. The dx is what? So it's going to be du divided by 4x cubed. Okay, we just do the substitution. So x would be cancelled out, x cubed, see x cubed, and x cubed. And the leftover here is 1, but the leftover here is 4. So there is going to be a leftover of a quarter. Okay, so what we are going to do is we are going to rewrite it as a quarter. You can pull it out directly if you like, but I write it down in 2 steps. Okay, so that gives a quarter of u to the -6 du. Now I pull out the quarter. So the leftover is going to be u to the -6 du as we predicted. Any question? So that was, the power was a -6. Okay, the power was a -6, and when we did it, we end up with a -6. Just apply the power rule. So it's going to be equal to what? It's going to be equal to the quarter up, move up, u to the -6 plus 1, which is going to be -5, divided by -5 plus the constant c. You have to take care of these denominators. You see this negative would be the sign of the fraction. It's going to be minus. Okay, it's going to be -1/20. Okay, and you have to bring the u to the -5 down. No negative power, remember, it's going to be u5 plus the constant c. So this negative is the sign of the fraction. Your fraction is negative. You multiply the denominator, 4 times 5 would be 20. Then you have 2 to the -5 on the top. You have to bring it down because we don't accept any negative power in our answer. You're not done, you have to change into the x. Okay, so this is going to be the final answer. -1, 20 times. 20 times u is x to the 4th plus 1. Okay, now raise it to the 5th plus the constant c. That will give you the final answer. Any question? So, it's a very nice operations. Just make sure you do the algebra all right. If it's getting complicated, sometimes you may miss the du. So you have to find the u and the du at the same time. So to end up with a function of the u times the du. Then it's just one formula. That's it. It's unavoidable. It's just one formula for all of them. Okay, to get these numbers done. Okay, that's going to be 1. How did I get the 1 on the top? This is it, u to the -5. I use the reciprocal. We flip it down. U to the -5 would be 1/u to the 5th. That's the formula for the negative power. U to the -5 would be 1/u to the 5th. That's it. That's why we get the 1 on the top. Okay, any question? So that is case 3. What is going to be the case 4? Look at this one. I repeat it again, but I drop this 6. If this power is going to be rational function, but the power is going to be 1. That is going to be case 4. Okay, so let's repeat it. Then I give you another one. You see, look at this one. It's a rational function, but there is no parenthesis here. So as we got this recommendation for differentiation, you are going to move it up. So what you're going to do is you are going to change, you take this denominator to be u, and if you simplify it, you must end up with 1 over u du. And you know that 1 over u du would be ln of u, and then you're done. Okay, so be careful. If there is a parenthesis with the power here, you move it up. But if there is no parenthesis, so this must be a kind of u prime u. Remember, u prime u is what? U prime u is the derivative of the ln u. So it's the same thing here. Okay, so now we are not going to rewrite it. We keep it as is, but we take that the part for the differential is going to be the same. So the u is x to the 4th plus 1. We repeat that procedure again. So the du would be 4x cubed dx. Then we find the dx as we did it. It's a du over, okay, du over 4x cubed. So go back, substitute. If you do everything all right, you must get 1 over u. So, and this is the given one, x to the 4th plus 1 dx, substitute. You don't have anything to substitute for x cubed, doesn't matter. X to the 4th plus 1 is u. And the dx, and the dx is the du over 4x cubed. Now the x cubed and x cubed would cancel out. So that give you 1, that give you 4. Again, there is a leftover of a quarter. So it's going to be a quarter. Okay, a quarter times 1 over u du. You pull out the a quarter out. So it's going to be a quarter of 1 over u du. And you know that 1 over u du is just ln function. So it's going to be a quarter of the ln of the absolute value of u plus c. Okay, you just substitute u and you're done. So the final answer would be a quarter ln of what is u? U is x to the 4th plus 1. So the absolute value of x to the 4th plus 1 plus the constant c, and you're done. Okay, so you got to be careful for those rational function. 2 cases. If there is any power here, just move it up. If there is no parenthesis, stay where you are. You must end up with 1 over u at the end to get, to get that number out. Any question? And so that was the 4 cases that we have. Now we have one case for the we did the ln function. We have one case for the exponential function. Remember, when you differentiate, if of e to the x is just e to the x, remember? But if it was e to the u, then we have e to the u times u prime. So we have something similar to that for this this integration. So we give a remark, and to get that one, that would be the 5th one. Any question? So give you a remark to get to the next one. Remark. The remark is this one, you see, if you have the integral of e to the u du, you know that the exponential function never changes. It's going to be e to the u plus c. So if it is anything other than the x, you have to call it u. And again, this is going to be where or when du is what? It's going to be u prime dx. So if you want to integrate any exponential function, you know, when other than e to the x, then you have to use the substitution method to get, you know, to get these numbers. So what's going to be the example for this one? To find this integral by substitution method again. Okay, we just continue, integrate by substitution method. Substitution method, or just substitution. Again, you know, these integrals, you have no other choice. Even if I don't say substitution method, after a while, you know, you just find out that the method that we have to use. But, you know, we give you that. So this means you have to go through the procedure. Okay, the u, the du, etc. Okay, of the form of the du is going to be this one. It's a very unique case. You don't have quite a lot. Okay, this is it, x squared e to the x cubed dx. You see the function? It's not e to the x, it's e to the something else. So you have to use the substitution method to do it. So for this type of problems, the u would be x cubed. You see, because you want to change it to the e to the u. So for this type of function, so this is going to be the case. So you take the u to be x cubed. Okay, u to be what? X cubed. Solution. That is the u to be x cubed. Then you find the differential of the u, du, u prime at x3x squared times it by what? Times by dx. Then we have to find the dx. So it's going to be the dx, you divide, that give you du over 3x squared. Okay, any question? We go back, we substitute, we must end up with e to the u. So let's see, it's going to be x squared e to the x cubed dx is equal to, it's going to be integral of what? You don't have anything for x cubed, x squared, don't worry. We keep it, e to the x cube is u, e to the u, times it by the dx. What's the dx? Dx is the du over 3x squared. Okay, now the x squared and x squared would cancel out. Remember, the target is e to the u. So there is a leftover. Leftover is 1 over 1/3. So it's going to be integral of 1/3. Okay, integral of the 1/3 e to the u. E to the u du. It's a number, you put it out. So that gives you e to the u du. And you know that integral of e to the u is just e to the u. So that gives you 1/3 of the e to the u plus c. You substitute for u. So that gives you 1/3 e to the u was x cubed. X cubed plus c. So that gives you the final answer. That's integral of x squared e to the x cubed dx. Okay, so in a case of the exponential function, if the exponent is anything other than the x, so you have to go with for the u substitution to get these numbers. And in the application case, in your case, you have a couple of very nice ones related to this type of problems. We have something we call it, supply demands equation, and the procedure would be in this type of form. And you sell something, then you get the rate of change of, you get the rate of change in your price, and then you want to find the actual price. Is going to be the same thing. So in those type of problems, you have to do this one. Any question? So for the exponential one, you must end up with e to the u. So whatever it is here, you call it u. Differential of the u is the derivative 3x squared dx. Then you have to find the dx. So the dx you divide by 3x squared, so that you will du over 3x squared. Then you go back and substitute. Okay, you must end up with e to the u. So over here, x squared and x squared cancel out, and the leftover is 1/3. So we put out the 1/3. Okay, we put out the 1/3, and then the leftover is going to be just e to the u, and then be done. Okay, any question? So the one that you see in application, you got to be a little bit patient to get these numbers true. These are the one that you have in your field, e to the. Okay, it's going to be kind of percent, e to the 0.02x dx. See, that top is going to be something like 2%. And when we change it, we end up with this one. You want to integrate it. Again, it's not e to the x. It's e to the something else. So you have to do it by substitution method. Okay, for the substitution method, you have to take the top to be equal to the u, and you end up with the e to the u du. Okay, so it doesn't matter even if you have to change something like 0.02x, but you have to use your substitution method. Okay, so we take this one. This is it, the solution. So we go with the u. U is going to be 0.02x. That's your u. You differentiate it. You know that the derivative of 0.02 is just 0.02. 0.02, but times it by the dx. Okay, now we have to find the dx. So what's going to be the dx? The dx is going to be equal to the du divide by what? 0.02. Okay, you can simplify 0.02 later. So that is going to be the dx and the u. Go back, substitute. If you do everything all right, you must end up with e to the u. So let's see, this original one, e to the 0.02x dx is equal to, substitute. So it's going to be e to the top is the one that you call it u. And then the dx, what is your dx? The dx is what? It's going to be du over 0.02. Nothing to simplify, there is a leftover. The leftover is going to be 1 over 0.02. So it's going to be equal to the integral of 1 over 0.02, then e to the u du. It's a number. You can put it out. You can put it out and then simplify it. So it's going to be equal to the 1.02 integral of e to the u du equal to 1.02 is like 100 over 2. You can use your calculator if you like. It's going to be 100 over 2. 100 divided by 2, that gives you 50. So that gives you 50. But integral of e to the u is just e to the u. E to the u plus the constant c. Okay, 1 divided by 0.2 is like 100 divided by 2, which is 50. And integral of e to the u is just e to the u. Then you substitute for u. So it's going to be 50 e to the, what was u? U was 0.02 2x plus the constant c. And then you're done. See, you will see this type of integrations when we get to we give a couple of application problems to get these numbers. Okay, any question? So this is a kind of 5 types of method of substitution that we can use to take care of these very, very famous problems. Okay, any question? Now there are a couple of VIPs, if you like, a good one, and I'm going to give you those 2. Okay, so get to know them. You may need it in future. I think you have one somewhere, I've seen one problem, at least. This true integral that I'm going to give you is going to be used in calculus 2 in the application, but it's nice to open up the method for you, okay? So you see other type of problems. The one that I did so far, you see inside parentheses, they were all polynomials. Okay, so you may have something else inside parentheses. Okay, so the VIPs, I give you 2. So that give you a better understanding of the concept. Any question? So far 5, and 2 more, 7. 7 type. We give you all of them. All of them in your next quiz and all of them on the final. Okay, so let's see what's going to be a couple of tricky one. Okay, the VIPs if you like. Again, integrate by substitution. Integrate by substitution. You have no other choice. Substitution or substitution? No, what's going to be those? Okay, this is the first one. Okay, something involving e to the x. Okay, for fun. How about this one? I think maybe you have it in your book. E to the x. Then this is going to be a square root of e to the x plus 1 dx. It's very popular. You can have it, inside the parentheses raised to something. You can have it as a fraction, as a radical, okay. All of them are going to be just a substitution method. And what are we going to do first to take this one? Any suggestion? What is your first action to do this one? Suggestion? What type of function is inside? You see the inside? It's a radical function. You know that in calculus we don't like the radicals. So you have to switch the radical. As soon as you switch the radical, you will see that this must be done by the chain rule type. Okay, so rewrite it. It's e to the x times e to the x plus 1 to the half. That's it. Okay, u substitution. Remember, inside the parentheses, whatever it is, you call it u. So you are going to call a u to be e to the x. You see, it doesn't matter. Previously, you have all polynomials. Now we have the exponential function. Why not? Nice. Okay, if you take this one u, and if you do everything all right, you must end up with u to the 1/2 du. Then you'll be able to do it. Okay, so we get this one to be u. So you have to find the du. So what's going to be the du derivative? Derivative of e to the x is just e to the x. Derivative of 1 is 0. So it's going to be e to the x times what? Times the dx. But we have to find the dx. Remember what's a dx? Dx, you divide by e to the x. So that gives you du over e to the x. That's it. Go back and substitute. So what's going to be the result? Start with this integral. Integral of e to the x plus 1 to the half dx is equal to, you don't have anything for e to the x, don't worry, it will be cancelled out. But the inside parenthesis is the one they call it u, so it's going to be u to what? To the half. Then the dx, what is your dx? Your dx is the du over e to the x. See? E to the x and e to the x would cancel out. So what are you going to get? Instead, you get, integral of u to the half du, as we predicted. You see, it doesn't matter whatever it is, just using your substitution, you end up with the power rule, which is u to the 1/2. Okay, now add is going to be u to the 1/2 plus 1 would be 3/2 over the 3/2 plus the constant c. This is a fraction. You flip it or reciprocal, that give you 2/3. 2/3 of u to the 3/2 plus the constant c. But substitute for the u. So it's going to be 2/3. What is your u? U is e to the x plus 1. So that gives you e to the x plus 1 to the 3/2 plus the constant c. You see, we can do very much complicated integral. So that was e to the x, the square root of e to the x plus 1 dx. You see, the key is just the beginning. And you realize that it's a radical function, you switch it, that's a type 1, we talk about it. All the problems that I did inside the parentheses was a polynomial. Doesn't matter. You get exponential function, whatever it is. Because it's important, the power is 1/2, so you end up with the u to the 1/2. And it would be quite, independent of whatever you did with those type of functions. Any question? So that tell you that how wide this method can be applied really. I told you, you don't have enough functions in your case. We have, if you bring those functions that you use in physics, okay, engineering, then this would be something else. Okay, any question? So that was with the exponential function. I'll give you one with the ln function. You see, look at this one, it's very similar. Suppose you want to find this integral, ln x to the 5th over x dx. Substitution method again. No, you see, you have a parenthesis raised to the 5th. So we take inside parentheses to be u. In this case, u is ln x. It doesn't matter, ln x. You see, in the other case, the u was e to the x plus 1. So if you take the u to be, okay, so this is it. So you take the u to be ln x. If you do the proper substitution, you must end up with u to the 5th. U to the 5th du would be u to the 6th over 6 and be done. But we have to prepare it. So that was u ln x, differentiate. You find the du. U prime, derivative of ln x is 1 over x. But times it by the dx. Now you have to find the dx. Cross multiply by x both sides. So that give you what? That give you dx equal to x times du. X times du. Okay, we take the u to be ln x. We differentiate it du. Du is 1 over x dx. Cross multiply both sides by x. So that give you dx equal to the x du. Go back, substitute. Originally, you have ln x to the 5th over x dx. Now we substitute. ln x is u, so that gives u to the 5th. You don't have anything to substitute for x, don't worry. Bring the dx. What's the dx? Dx is like x du. You can think about x du over 1. So the x and x would cancel out. So you end up with what? The one that you predict, u to the 5th du. Action of integration, power up, is going to be u to the 6 over 6 plus c. You substitute for u is ln x. Ln x to the 6 over 6 plus the constant c, and then you're done. That's it. That is method of substitutions and all the possibilities that you're going to have to get these numbers. Okay, Again, you don't have anything else. You see, I give you all the possibilities in this case. And we are going to use them, in future in the applications that we are going to have. That is going to be one. How we determine what's going to be the U? U is the power function. Inside parentheses is U. Inside parentheses is U. It's the power rule. Okay, inside parentheses is U. That's all the game, okay? Because it's called the general power rule. So you are going to have a power function, okay, a power function, and you just take this one to be U. Because your formula is what? Your formula is U to the n. That's exactly what you did for the chain rule, remember? When you want to differentiate, the inside parenthesis is U is a power function. The power function means something raised to, to the power. So over here, you see, it's what to the fifth, ln x to the fifth. So U is ln x. The previous one was e to the x plus 1 to the 1/2, you see. So U to the 1/2. Because you want to make it into the U to the n all the time. So that's just the power function. In your case, this is going to be the only one. Okay, I can give a break now. And we get 10 minutes, we come back, we are done with the substitution method. I have at the university, we have done with this part, and tomorrow we are reviewing for the test 3, we call it over there. So I give them a review. I can show you the substitution one, and then we can do it together. So I put it over here, you can have a look, and then we can do it. This is their take-home quiz. You are going to get one when we get to your parts. Okay, let me just share it with you. You can have a look, and then we can check the solution. So just go back. Can you see it? So that's the take-home quiz number 7. They have your test on Friday. It's a test number 3, and this is all integrations that we're going to have. Okay, and the substitution one is this last part. You see, 1, 2, 3, 4. 4 types. Just think about it. You can think about during the break, and we come back and we do it. We can give you some extra points if you can do it. Okay, this is exactly the 4 case. I gave you 2 extra. I didn't give them that last 2 questions that I gave you. I didn't discuss it over there, but there is going to be an exponential one is missing because we need 5 types. Okay, it's just 4 types because we didn't do that one over there. Okay, so you can have a look at it, and then we come back, we just do it together. Okay, so see you in Okay. Do you have any answer for this problem? Anybody want to try? Number 5, part 1. Part 1. For the substitution method. So look at the one, you have to pick the U inside parentheses. This is going to be inside parentheses. Okay, this is the one that you're going to call it U. Okay, so you call this one U. You must end up with the U to the 4th du. So your U is going to be x cubed plus x squared plus 7. Okay, you find the du. You see, you find the du. The du would be what? It's going to be 3x squared. Okay, 3x squared plus 2x. You already got it. So if you go back, substitute that, you end up with the u to the 4th du. So the result would be u to the 5th over 5 plus c, x cubed plus x squared plus 7 to the 5th over 5. The next one, you change it to the 5x plus 4 to the 1/2. And you take the u to be equal to, okay, your u is going to be 5x plus 4. So that gave you 5x plus 4. Okay, you find the du, you substitute. I'm going to do it for you, so it's good to know. Okay, let's just go back to my. So this is a sort of question 2 more. You get 7. Okay, of this type. So let me just go back to my notebook and do it for you. Okay, so you will get a similar one for yourself, a method of substitution. So example, we want to integrate by substitution methods, integrate by substitution. Okay, that was the part 1, integral of. I better get back for myself. See, where did I put that? Yes, I have it here. So the first one was integral of 3x squared, 3x squared plus 2x times it by x cubed plus x squared plus 7, everything to the 4th dx. You see, for the substitution method, you are going to pick the u to be whatever it's inside the parentheses. Okay, so if you take this one to be u, you must end up with u to the 4th. That's how you pick, you pick the u. So the u is equal to x cubed plus x squared plus 7. That's going to be your u. Differentiate. Du, derivative would be 3x squared, 3x squared plus 2x, but times it by dx. Now you have to find the dx. So the dx would be du divided by 3x squared plus 2x. Okay, so that's going to be u and the dx. Go back, substitute. Everything should be canceling out, and you should end up with u to the 4th. So originally, this is what you have. You have a 3x squared plus 2x. I have to repeat it. Times x cubed plus x squared plus 7 to the 4th dx is equal to. We don't have anything for 3x squared plus 2x, so we repeat it. We hope to be able to cancel it out. Okay. The next part, this is u. So that gives you u to the 4th. Then times the dx. What's going to be the dx? The dx is du over 3x squared plus 2x. Now we get a chance to simplify, you see. You cancel it out, so the leftover is going to be is integral of u to the 4th du, as you predicted. You see, whatever power you have over here, you must end up with that power. Now, the action of integration, you move up, so that gives u to the 5th over 5 plus the constant c. Now you substitute for u, so it's going to be equal to your u is this one. So that gives you x cubed plus x squared plus 7, everything to the 5th, divided by 5 plus the constant c, and then you're done. Any question? So it doesn't matter really, the most complicated one, we can do it. Just the method is a power function. That's your u. So you get the du, you go back, you simplify, you must end up with u to the 5th, unless, unless you just miss something in the algebraic operation that you have. Okay, question? So that's type 1. The type 2. What is the second part? The second part is a radical function, type 2, the square root of 5x plus 4 dx. That's a type 2 that we talked about it. So since it's a radical function, we have to switch the radical. Switch the radical into the 5x plus 4 to the half. So for the solution, we have to rewrite it. So you end up with the 5x plus 4 to the half dx. Then inside the parentheses, you call it u. So you call u to be 5x plus 4. So you must end up with u to the half. U to the half du. So find the du. So what's going to be the du? We differentiate. The derivative of a 5x plus 4 with just 5. But we have to multiply by dx. Now you have to find the dx. So what's going to be the dx? Okay. So we have to find the dx. So the dx is going to be equal to, dx is going to be equal to the du divided by 5. Du divided by 5. So that's going to be your dx and the u. Go back, substitute. So this is what we have, integral of 5x plus 4 to the half. Dx is equal to, you substitute, the inside is u, so that gives u to the half. U to the half times the dx, what's the dx is what? Is the du over 5. There is nothing to be simplified. So you have 1/5. So it's going to be integral of a 5th. Okay, a 5th u to the half du. So you pull out the 5th. So it's going to be a 5th integral of u to the half du. That's it. So we get to the u to the half du as you predicted. Now we integrated the power rule, a 5th u to the 1 up. 1/2 plus 1 would be 3/2. 3/2 over the 3/2 plus the constant c. We have a fraction down the denominator, we flip it, reciprocal. So it's going to be equal to a 5th times the reciprocal of the 3/2 would be 2/3. 2/3 u to the 3/2 plus c. So that gives you 2/15 u What is u? U is 5x plus 4. 5x plus 4 to the 3/2 plus the constant c, and do that. Any question? So that's the radical type. That's going to be now the type 2. You switch the radical, you get parentheses, raised to something, you have the power function inside, you call it u to the 1. It's all a standard operation that we're going to have. Okay, that's type 2 question. So let's check the type 3. Type 3 and the 4 would be rational function. One in which you don't have any power, you take care of it by the ln function. And the other one that is going to be a power, you have to switch it. Okay, so that would be a 2 question. It's 4 integral. We write it down as a 2 question, and it's going to be 2 parts. So this is it, integral of 1 over 5x plus 1 and dx. See, that's going to be the next one. You see, it's a rational function. There is no parentheses. So you're not going to move it up. You stay where you are. And you take this one to be equal to the u. So you must end up with 1 over u, which is going to be the natural log. Okay? So don't move it up, then you'll be confused. Solution. You take the denominator to be u, 5x plus 1. If you do everything all right, you must get 1 over u du. So we have to find the du. We differentiate the derivative of 5x plus 1 is 5. But times it by dx. So we have to find the dx. The dx is du over 5. Go back, substitute. If you substitute, you must get 1 over u du. So this is the function. Original one, 5x plus 1 dx is equal to integral of 1 on the top, 5x plus 1 u, 1 over u, dx. What is the dx? Dx is the du over 5. Again, nothing to simplify. You get the leftover of the 1/5, so you can put it out. You can rewrite it, then you put it out. So it's going to be integral of 1/5, 1 over u du. You pull it out, so that gives you 1/5, integral of 1 over u du. You know that 1 over u du would be ln u. So this would be 1/5 ln of the absolute value of u plus c. But you substitute for the u, so the result is 1/5 ln of the absolute value of 5x plus 1 plus the constant c, and then you're done. So it's a rational function. If it's a rational function, no parentheses, no power, so automatically that should end up with the ln function, 1 over u du. You see, 1 over u du, and you know that 1 over u is the derivative of ln u. Then you substitute. Any question? So that's going to be the type 3. The type 4 is if there is any power here. And that is the case for the last part. So this is going to be the part D. You have quite a lot in you just better look at the assignment of these 2 sections. You get quite a lot of these type of problems. Okay, so this is the rational function type. Okay. So it's a rational function, but there is a power here. See, when you compare them together, No parenthesis for the other one, but there is a parenthesis here. So you have to move this one up. And then, you know, you get a power function inside your integral. So rewrite it. So you end up with what? 4x times 2x squared plus 3, everything to the negative 8 dx. See? The power is here, so this would be your u. 2x squared plus 3 would be u. You must end up with u to the negative 8. So pick your u. U is 2x squared plus 3. That is going to be the u. Differential of the u, derivative, 2 times 2, 4x, and then the dx. Find the dx, which is going to be the du over 4x. Go back, substitute, simplify. You must get u to the negative 8. So we take it from here. It's a 4x times 2x squared plus 3 to the negative 8 dx is equal to, it's going to be equal to the integral of, we don't have anything for the 4x, no worry, because it's going to be canceled out. Inside parentheses is u, so that gives u to the negative 8. And the dx is the du over 4x. So these two would cancel out. So the result is going to be integral of u to the negative 8 du, as we predicted. So move up, that gives you integral u to the negative 7 over negative 7 plus c. No negative power, no negative numbers here. So this is going to be minus 1 over 7 u to the 7 plus c. Because the negative power, you know that you flip it. Now you have to substitute for u and then you're done. So 1 is going to be negative 1 on the top. And 7, and the u is 2x squared plus 3, everything to the 7 plus the constant c, and then you're done. See, as you can see, it's not going to be a difficult procedure. So make sure you know these 4 types of integral. Of course, there is no exponential here, the one that I did. So if you add that one to this collection, it's going to be 5 types. 5 types of integration, and we are going to come back to it again. This is one version of this type of problems, the substitution method. Okay, any question? So that's a 5-2 and the 5-3, the substitution method. No, we did have all, you know, so far we have all the methods for integrations. So what we did so far, we just look at this integration as a machine, okay, as an operator. We have some formula, we just put them together and going back around. But the reason that we create these type of ideas is to solving the second problem of calculus, or the last problem of this course. And that second problem is going to be the area problem. Okay, remember the first part of the calculus, we did the tangent line problem, okay? So we create the derivative, we call it the slope. Now we're going to use integration to find the area under a curve, if you like. So that area eventually is going to be evaluated by these integrals. But we are going to introduce a new type of notation, new type of integral to be able to do it. Okay, so let's try if I can give you an introduction to that idea tonight, and then we finish it on Thursday, and then be done with everything we need. There are a couple of more applications, but the main topics is going to be done. Okay, so let's see what is all this about, if you like. Okay, so you did all these problems. So what's next? What's going to be next is going to be answering that problem of the area problem. Okay, so that was 5, I think 2 and 3. Okay, so this must be 5.4. Okay, in 5.4, we are going to solve the area problem eventually, and the result is going to be called a new integral. Okay, and we call it a definite integral this time. But let's see what's going to be the idea, then I tell you what's going to be the result. Now, you see, this section starts with the question. So the question is going to be, you see, this is going to be the question. I just want to motivate the subject, then I give you the result. So the question is going to be, would like you to find the area of each region, Okay, to see what's going on with this new notation I'm going to use. Okay, let's start with this one. You see this one? This region is a triangle. So the area of a triangle is easy to find. We have a formula for it, remember? If you see the area of a triangle, if you get the height here, okay, this is going to be the height h, and this is going to be the base. So the answer is going to be, the area is going to be what? It's going to be 1/2 of the base times the height to get the result. Okay, so this is going to be the base. This is going to be the base, and this is going to be the height. So if it's a triangle, it can be done. Okay, any question? So what's going to be next? How about if you have a rectangle? You see? We want to find the area. Just we assume that we know only the area of a triangle. Okay, we know that there is a formula for it. But if you want to do it just using the area of a triangle, what we can do, we can divide it into 2 parts. We can divide it in 2 parts. Okay, so we divide into 2 triangles. So the area would be what? Would be A1 plus A2. Since you can find the area of a triangle, so you can find the area of the rectangle. But we know that there is a formula for it. So the formula would be length times the breadth, if you like. So we are done with the rectangles. I want to show you how calculus fit comes to this problem. Okay, what next? So the next one is going to be, how about if you get a polygon? See, how about this one? Remember, you know only the area of a triangle. Any suggestion? If you know area of a triangle only, so how are you going to find the area of this region? Any suggestion? How we're going to do it? What we did for the rectangle. You see, for the rectangle, we just cover it with 2 triangles. So what we can do for this one, we can do the same thing. And this is the way we do it in geometry. We can divide it into some rectangles. See, look at the rectangles. We get some rectangles. So we cover it with some rectangles, and we know that some triangles, sorry. So we know how to do the triangle. So, we get the A1 if you like, A2, A3, and A4. So A is going to be equal to the A1 plus A2 plus A3 plus A4. We know that there is a formula for it, in geometry, but we don't care. Any question? So this idea is called the partitioning method. So we partition the area, okay, the region, in this case by some triangle to be able to find it. Okay, any question? Now these are nice. You see these areas, we call them rectilinear shape. Rectilinear means the sides are just a straight line. But if you go to the beach, okay, go to Oceanside, then the beach is not going to be of this form. There are some curves, okay, some straight part. So if you want to find the area of the beach, so you cannot use this type of ideas. So let's see if you have a curvilinear shape. The best curvilinear shape is a circle. So how are we going to find the area of a circle? We know that, don't say it's a pi r squared. Yes, we know that's pi r squared. But we want to use this idea of the partitioning. And this is what they did at the beginning. This method that I'm explaining to you is was done by Archimedes for the first time. And he created calculus. So what's going to be the suggestion for this one? Of course, you cannot cover it up in this format because it's a circle. It's not a straight line. So what we can do, we can approximate it. This is where the calculus is coming. Remember, the calculus is the arts of estimation. So what we can do, we can estimate it, you see. We can estimate it by what? We can estimate it by a polygon inside. You see? If we get this polygon inside, of course, we can find the area of the polygon, which is going to be A1. So the area of a circle is going to be approximately A1. When it's calculus, it's approximately. Any question? Now, you say there are very much left over here. So we can do better. You see, we can do a better partition in order to cover this leftover. In order to cover this leftover, you have to increase the number of the partitions, okay? So you have to partition it finer, a finer partition. The finer partition means use more points, you see, if you use more points. So this is going to be the one. So this one is better. So the area would be approximately A2. If you want to do better one, you can estimate it, you can partition it finer again. So increase the number of the partitions. If you increase the number of the partition, you see, you get something, this is it. That's a better one. Okay, that's going to be A3 if you like. So if you pick the number of the partition to be n, okay, so you are going to have a sequence of numbers. You see, the first one you get A1, the second one we get the A2, A3, and you just keep going. We get the AN here. These are going to be a set of numbers. So eventually this, if you take the limit of AN, limit of these numbers, when it goes to infinity, that gives you the area. That's where the calculus is coming. Archimedes, he just estimated. He didn't say the limit at that time. But with this partitioning one, eventually he proved that, the area, that today the area is going to be pi r squared. And we just do it right away. But this idea of the arguments, he just called this method of exhaustion, because you have to increase the number of the points, to exhaust, if you like, all the regions, all the leftovers, to get, to get these numbers. It's like you have a piece of cake. If you have a piece of cake, you may cut it into the different. Okay, you can cut it into different kind of circular disc, if you like. But there are going to be a leftover when you cut it. Okay, if you have a piece of cheese, if you cut it into the different parts, different rectangles, cubes, rectangular cubes, and eventually there's going to be some leftovers. Okay, but you try to get this leftover as small as possible. So that was the idea of the arguments. But in calculus, we don't have a circle. We have a function. Okay, so the main question is going to be the next one. That's a birthplace of calculus. This is the first time that, today we do the other way around. We do the derivative first and we get to this. You see, that's the one we call it area problem. What is area problem? That was done by, again, Archimede for the first time. So the area problem is we would like to find the area of the region enclosed by the graph of the function, graph of the, let's say, y equal to the f of x from x equal to the a to x equal to b. We call it the area under the curve. You see, this is a situation we have. See, this is the graph of your function, for example. This is the graph of your function. And this is going to be A. And this is going to be B. So the question is going to be how we're going to find the area of this region. You see, the region that enclosed by, you see, from the bottom one enclosed by the x-axis, from the top one by the curve, to the right, to the left, but x equal to the A and x equal to the B. So in order to get this area of the region, the Archimede just used the same method as with the circle. So what we're going to do, we're going to cut it into pieces. We partition it, you see? We partition this one into different parts. And we draw some lines here, you see? Then we are going to cover it. We can cover it with rectangles. We can cover it with, triangle. But the best way to do it is cover it by some rectangles. You see, that's going to be the one. So we can cover it from inside. Just give you more points, so I'll be able to do it. Okay, so this is going to be the case. So what we can do is we can make some rectangles here. Okay, some rectangles. Okay, so the area of this curve, if you like, the area is going to be approximately, these rectangles that we have. It's going to A1, A2, A3, up to the AN, if you like. Okay, now, if you want to find the area of one of these rectangles, so look at the area. This is one of these rectangles. So to find the area of a rectangle is the product of two dimensions. It's going to be this portion over here. Since we divide equal parts, we call this portion to be delta x. Okay, and this portion over here. This portion over here, this height is going to be just the y-coordinate of the points. It's going to be a value of the function at a point. We call it, C. Since it's going to be 1, 2, 3, 4, 5, 6, we call it CI. So the area of this, the area AI, is going to be f of CI times delta x, when I can be equal to the 1, 2, 3, up to the n. Okay, so we partition it, we cover it by 5 rectangles, 10 rectangles, 1,000 rectangles. So you have to find the area of each rectangle. The area of each rectangle is going to be just a product of 2 dimensions. The dimension on the x-axis would be just depends. We divide in equal parts. If it's going to be between 0 and 1, you divide the 1 into the 10 parts, 100 parts. Each part we call it the delta x, and this is going to be just the y-coordinate of the points. So the area in question is going to be something like this one. It's going to be approximately the area of the first rectangle is going to be f of c1 delta x. The second one would be f of c2 delta x, and then you continue to get to the last one. And I want to arrive at the formula, give you definitions. So justification. Now we can combine them together. We use the so-called the sigma notation. If you have seen this notation before, if you haven't seen it, don't worry, we are not going to use it. So I from 1 to n. So this sigma notation means we replace the I by 1, that give you f of c1 delta x plus I by 2 f of c2 delta x plus. Okay, so we get this is going to be approximated the area. Again, like a circle, if you want to get the exact number, you have to increase the number of the partition. So eventually the area would be the limit. The limit of the sigma of f of ci delta x, I from 1 to n goes to infinity. That would be the area. When we teach calculus 1, 2, 3, we find it. But in your case, we are not going to do it because we want to take this one to just introduce, okay? We want to introduce a new notation, if you like, to get this formula for you. The new notation is going to be this sigma form. Okay, we change it into the format of a new integral. You see, it's going to be the integral. This f of c would be f of x. We change the delta x into the dx. And since it's the area from a to b, we use this notation, a to b over here. So we introduce the area to be integral from a to b, f of x dx. This new notation over here is going to be called definite integral. Or the guy who created is a German mathematician. His name is Riemann. We call it a Riemann integral. Riemann integral or a definite integral. In your case, we are going to define it quickly as the area under the curve. But in practice, we do something else to get through it, but you don't need it. So that was just a motivation for the definition I'm going to give you, and then I'll come back and show you how we're going to find it. So we just using the arts of calculus, if you like, to estimate this type of problems. And this is just, area is just an excuse, really. This is the foundation of all science. For example, a statistic, if you have done a statistics, you need probability. This is probability, the integral. If you are going to be in physics, various notions in physics would be defined by integrations, these type of integrals. So instead of staying with this method over here, we are going to take all of them as a definition. Okay, so that was the motivation, but in your case, you need only the following. What is going to be a definition of a definite integral? Definite integral. Or if you like, a Riemann. Riemann, just German mathematician. Riemann integral. Just go with the definite integral. So what is going to be a definite integral definition? If f is going to be a continuous function, a continuous function on the closed interval, on the closed interval, a comma b, then the area of the region enclosed by the graph of y equal to the f of x from x equal to the a to x equal to the b is called the definite integral. Definite integral of f, of f over the interval. Definite integral of f on the closed interval of a and b, and is denoted by a equal to integral from a to b f of x dx. The one that we did before, you see, you didn't have the a and the b. The result was a function. This is going to be a number because the area is a number, okay? So the definite integral on a and b, and is going to be denoted by a equal to the integral of a to b f of x dx. Okay, what we are going to do is the question is how I'm going to find it. I mean, you cannot, sketch the graph all the time and find the area under the curve. It's not possible. So we have to do something about this one. You have to find a method to find this integral. Okay, and that method would be connected to the one that we did. I think that would be enough to give you an idea, but we are going to start it over with this definition on Thursday. And if we don't need any formula, we're already done with the formula that we have. You see, in the history of calculus, they did the definite and indefinite integral separately. A group of the people from, from engineering or the physics, they were doing antiderivative. And the group of the mathematicians, they were using the area problem. But there is a theorem that will connect both of them together. That theorem is going to be called fundamental theorem of calculus. I'll talk about that one on Thursday, and then we finish everything. We don't need any new formula, but we have to get through this one. Okay, so focus on the substitution method. We come back to this one. We started from here on Thursday, and we finish everything, then we can review on on Tuesday, I think. Then give you the quiz on Thursday, and then the last week we're just reviewing for the final. So this is going to be the plan. So your job is to take care of substitution method, which is going to be 6 questions, as I told you. When you combine it with this one, that gives you the 6th question in future. Okay, that's it for tonight. Any question? That is going to be, but that the final is going to be question similar to question. No, the final would be covering test 3 mostly. Test 3, quiz 4. There are going to be 3 questions from the beginning of the course, but most part of the final is test 3, okay, and the quiz 4. From the quiz 4, you are going to get 6 questions. 6 questions from the quiz 4, okay, and then because I think we give you 16 questions on the final. I will post the final review for you so you see it. That's going to be the one. From the derivative at the beginning of the course, we just give you the chain rule. Derivative of exponential function, everything is going to be test 3, but it's mainly test 3 quiz 4, the topics that we have. Okay, I will grade the test 3, then we can talk about it. Okay, have a good one. And Noel, I'm waiting for your question. What's your question? I can answer the question now.
I was wondering, I got a little confused for the homework on 11 and 4.1. It's about graphing.
11, 4.1?
Yeah.
Let me check. Eleven 4.1, y equal to 2 to the x minus 3. That's the one that you want?
Sorry, yes.
So we just substitute some numbers and get it.
I was asking for graphing, so I got a little confused.
You see the sketch the graph. 2 to the x minus 3. That's the question. So at this level for this, as they talk about it. So as you just collect some numbers and just graph it. X, Y. Pick 0, 1, 2, -1, -2. You collect this point and graph it. 2 to the 0. It's going to be 2 to the 0 minus 3. It's a 1 minus 3, which is a -2. So this gives you 2 minus 3, which is a -1. A 2 squared minus 3 would be 4 minus 3, which is 1. -1, 2 to the -1 minus 3 would be 1/2 minus 3, which is going to be -5/2. And then -2, 2 to the -2 minus 3 would be 1/4 minus 3. Okay. So that gives a -11/4. Because these are the algebraic one, it's not calculus part. When they talk about this type of graphing, it's different. You just locate this point and connect them together. You get the 0 and -2. Okay, x equal to 0, y -2. This is going to be 1 point. Then you get a 1 and -1. So this is going to be 1 and -1. Another point. Okay, then we get the 2 and 1. This is going to be 2 and 1. Okay, this is a 2 and 1. We get -1, -1 and the 5/2, which is 2.5. So this is going to be 2.5. Then we get the -2, -2 and 11/4, which is almost 3. So you just connect these together. Give you, almost the graph. And they ask you, that this, the one that they got this symbol, this means you can use your calculator to graph it. So that's 11. Okay, that's number 11.
Let's see.
Yeah, section 4.1 is all algebra. It's not the calculus part. just remind you, what you did. And you can use graphing calculator to graph it. You can graph 2 to the x. This is the way you did in college algebra. In college algebra, we do 2 to the x first. This is 2 to the x. Okay,